What is going on, fellow makers? Frankie here, and today we're going to be looking at some of my recent 3D models that I will be submitting to the Pinshape Mechanical Design Contest. They are linear combination locks that you can use for locking various things around your house, or if you trust it enough, lock your bike to a public bike lock. So, let's get started. Autodesk's 123D Design CAD software is the software that I use to design these locks. If you have it, I could totally recommend using it because it's a really good beginner's CAD software. And if you don't have it, unfortunately, Autodesk just discontinued the program back in November. Now, before we begin, we are going to need a few things. Notably, some plastic cement or glue will help us out a lot in post-processing. If you plan on making one of the smaller locks, I would recommend getting some nylon or some thin steel cable, as this will help us create a very durable lock in the end. It should be something that can't be easily torn. And if you plan on making one of the larger locks or a bike lock, I recommend getting some chain links from your local hardware store. I found these at my local hardware store for roughly $1.50 a foot. It's pretty cheap stuff. I'll pull out my calipers here and show you the measurements of these chain links because the designs on Pinshape are based off of these measurements. Now, when I was making my locks, I actually found that these chains were a little on the small side, so you could probably go for something a little bit bigger here. And eventually, I'll stop measuring these chains and just throw them aside for now because we'll worry about that later. We are going to need a heat source for post-processing. I opted for this lighter that I use to melt the isolation off of wires when I'm soldering. And an X-Acto knife or a flathead screwdriver will help us shape the melted plastic. If you want to create a bike lock or add some chains to the 3D prints to make them more durable, just wait until the printer has basically finished part of the base of one of the halves, and then slow it to a snail's pace of its original printing speed. I used my little spatula/scraper tool to position the chain in its rightful place. It took a couple tries, but eventually I was able to slot it into one side of the base and then kick the printer back up to 100% of its original printing speed. I print at roughly 60 millimeters per second using Cura Slicer software by Ultimaker. All the settings will be over here on the left, so you can confirm that in your slicer software. And I printed this at roughly 10% infill because it's a demo, and actually when my friends field tested it, 10% can be a pretty strong lock. So the next step is a pretty crucial step here. This is one of my many prototypes that I've had lying around the house ever since I started designing this lock. And you can see some of the overhangs here on the end are a little messed up, just to say the least. And there's actually a simple way we can fix this. If we just take our heat source and heat up the very end of this half of the lock without setting it on fire, because trust me, it's a catastrophe if you do, you can use your flathead screwdriver or X-Acto knife to mold some of the melted plastic back into a crisp 90-degree overhang. If your overhang is not crisp, then there's a chance that the end ring will not fit properly on the very end of the lock, and there's a chance you could break the lock while trying to put it together. And that is surely not a good thing to have. So, looks like these overhangs are pretty good. You can put the X-Acto knife away, and you can also put the heat source away, as we will not be needing them in the future. And here we are back at the 3D printer again with a couple of rings that we are going to need to complete this process. I print the digit rings in batches of 6, but no more than 6, because when I attempted an 8-digit ring print, I saw about a success rate of 75%, and that's not good for a 2-hour print. So right here, this is the smallest of locks that's included in the Pinshape download. I figured I'd feature it for this little assembly process. And you can put everything together as you would with really any of these 3D printed locks and make sure that everything fits together and moves smoothly. And then get ready to take it apart because now it's time to do some gluing. So if you put the whole thing together, be sure to remove the end ring and don't be like me and try and use a pencil because the pencil will surely break before the end ring comes off. Once I finally popped off the end ring, I just set it aside and then took off the digit rings and set them in a stack nearby. Now, the smallest lock needs a bit of special treatment. If you use the bigger locks, then surely you would just add the chains to the print as it is printing, as I showed you earlier. But if you're using the smaller locks, I would recommend using some of the nylon twine or steel cable and just thread it through the very bottom of the lock and then tie it down a few times to ensure that it stays in place. If you really want to, and I would recommend it, add some glue to these joints as it will really contribute to the strength of this lock in the end. Once everything is tied down securely, you can check to make sure that the lock is together and everything is durable and nothing's going to break. Nothing really should have shifted during this whole process, so you can keep that close by as now we are going to focus on the end ring. Now, this is where the plastic cement comes in. So, regardless of any lock that you made in this download, you're going to have to do this process. So, what we're going to do is open our lock, or whatever halves of it we have right now, and then we're going to take the end ring, and we're going to apply just a little bit of plastic cement around the inner walls of the end ring. Now, this is going to ensure that this ring stays on the lock, as it is the only ring in the entire lock that does not move. So nothing too fancy, not too much glue, just a thin band around the inner edge. And then once you've done that, go ahead and put your digit rings back on. That's why it's helpful to have them in a tower. And then just take the end ring, and what I tend to do is I set it down on the table, and then I line up the notches, and then just press the cylinder half into the end ring. Now, as you'll see here in a minute, I actually ended up putting the end ring on in the improper orientation. Now you can tell because the grooves do not line up here. So frantically I recognized my mistake and then tried to pull the whole thing apart before the glue set, and actually ended up launching a couple of the rings across my room and had a heck of a time trying to find them later. Once you get the end ring on, hopefully in the proper orientation, just go ahead and twist it until it locks into place and that all the grooves line up properly, and ensure that the digits still spin, as if any glue seeped over into the digits, now is the time to clean that up. Now, if you really want to, you can add a little bit extra plastic cement to the notches where the end ring fits, and this will ensure that those are not going to break at all throughout normal use, as the plastic cement will pretty much cement the plastic to the rest of the lock. I used a toothpick here to spread some of the plastic cement around, and in the end, it actually turned out pretty good. So after you've spread some of the plastic cement around, you can just set it down and let it dry for about 2 hours, and then we'll be ready to continue the rest of the process. And here is the final product. As you can see, this is one of these 6-digit locks that I printed at 10% infill, and it's pretty strong. It's able to withstand my everyday use. A recommendation when entering the combination into these locks is using your thumb to hold down the digits that you've already entered. Why do I recommend this? Because sometimes the rings will bind up with each other. It just depends on the overall quality of the print, and that ensures that you will be able to open your lock on the first try. In the Pinshape download, there are 2 files for the rings. There are the normal rings and the low tolerance rings. I would use the normal tolerance rings for pretty much any project, because they don't have to line up perfectly with each other in order to unlock the lock. The low tolerance rings do have to line up perfectly, however, and the only place I would see that being practical is on the 2-digit lock. Yes, these locks are hollow on the inside. The 6-digit one can fit a dollar bill on the inside, and I actually keep one in my pocket for that exact purpose. And that is pretty much all I've got time for today, you guys. Thanks for watching this video. Please go like my designs over on Pinshape. Please like this video. It really helps me out as a creator. I'll have all the links in the description so you can go check it out. Thanks to Pinshape, thanks to Formlabs, Adafruit for putting together this contest. It's a huge opportunity for us makers, and I would actually recommend going and checking out some of the designs on Pinshape, as there are a lot of really cool designs that have been popping up there lately. And that is pretty much all I've got time for today, guys. That's it. Frankie out.